speed, yep, then we get the inputs, and over here on the handle movement function, yep, for the movement distance, we have move speed multiplied by time.time. Or another use case over here on the stove counter, we've got a frying timer, and how we count it down, again, is the same thing, time.time. Well, it turns out that behind the scenes, time.time actually already has a multiplier. When you access this, it is after that multiplier calculation. So over here on the pause game function, we can just go into time, and we can modify the time scale. This one is the multiplier, so if we just put this at 0f, then that's it. This is going to pause all of the other delta times. So let's test. So here we are, pay attention to that and the countdown timer, and I press on escape, and there you go, everything pauses. The countdown timer pauses, over here the script pauses, and I can no longer move, nothing works, everything is perfectly paused. Alright, awesome, everything works. Except one problem, obviously right now we cannot unpause. If I press escape, it's not unpausing, so let's do that. Over here on the kitchen game manager, let's add a simple bool, so a private bool. Let's call it isGamePaused, and let's default it to false. Okay, so isGamePaused. And then down here on the pause game function, let's simply flip this one. So we set this one equals not this one, so that is going to flip that boolean. And then we check if the game is paused. If so, set it to 0f. And if not, then we're going to set the time.time scale back into 1f. Okay, so now this should pause and unpause. So let's actually rename this function, since this is no longer just going to pause. Let's rename this to toggle pause game. This is going to pause and unpause. Okay, so let's test. Okay, so here we are, everything is running. Now I pause, and there you go, everything freezes. I cannot move, the arrow is stopped, the countdown is stopped. Now I press again, and there you go, nice and resumed. All right, great. So all of the logic is working perfectly. The only thing we need is really just a visual. And as usual, let's separate the logic from the visuals. So let's go inside the canvas, let's go into the scene view, and inside the canvas, let's create an empty game object. Call it the game pause UI. Then let's stretch to occupy the entire screen, so 0 on everything. Okay, great. Now inside, let's first of all add a background. So a new image, name this the background. Let's once again stretch to occupy everything. And on the color, let's put it in black with just a little bit of alpha. Okay, just like that. Then let's add some text. So let's create a brand new UI text. Let's name it pause text. And in here, let's just say paused. Let's just make it big, so the width and height both on 0. Let's disable wrapping, put it centered down the middle, and let's increase the font size by quite a bit and put it in bold. And let's also change the color, maybe a nice yellow, something like this. Okay, that looks pretty good. Let's just lift it up by a little bit. Now let's make a script to show this. So on the UI folder, let's create a brand new C# script. Call this the game pause UI. Let's attach it and open. Now here, let's do the usual thing. So let's make two show and hide functions. So a private void show, and then a private void hide. So on the show, game object set active into true, and on the hide, set it into false. Okay, that's it, pretty simple. Now we need to know when to show or hide these functions. So over here on the kitchen game manager, let's make two events to do that. So let's go up here, make a public event, event handler. And let's name this on game paused, and another one for on game unpaused. Okay, we have both events. Then down here on the toggle pause game, if we have this one timescale 0, that means we have pause. So let's invoke the on game pause, this event_empty, okay. And on this one, let's trigger the other one, so on game unpaused. Okay, we've got the two basic events. Now back here on the game pause UI, let's listen to it. And as usual, let's do it on start, so private void start. Let's go into the kitchen game manager, access the static instance, and let's listen to the on game paused, and then going to listen to the other one, so the instance on game unpaused. So listen to both of them, and as usual, let's write good clean code. So let's rename this. So kitchen game manager, and on this one the same thing. So also the kitchen game manager. Okay, we have both. And when the game is unpaused, then we want to hide the pause window. And when the game is paused, then we want to show the pause window. And finally, of course, we want to hide it by default. So over here on start, after we add listeners, let's just hide it. Okay, so that's it. That should work. So let's test. So here we are. Everything is running. Now press the pause. And there you go. Got a nice pause window. Press again. And there you go. Everything resumes. Okay, great. So the last thing that we want is just a button over here to go back to the main menu. And let's also add a button to resume without having to press the hotkey. So over here, let's create a new UI. Let's make it a button. This is going to be the main menu button. Now let's make it quite a bit bigger. Okay, width and height of 30 and 80. Let's put this one quite a bit down there. And inside for the text, this one is the main menu. Let's put the color in white, and the background for the button, let's put this one in a dark gray. And let's also, just for fun, add a nice outline, and let's also add a shadow. For the outline, let's put it on full alpha, and let's put it on about 3.3. And for the effect on the shadow, 5 minus 5. Okay, so that adds a nice outline and a nice shadow. And then for the text itself, let's put it in bold and raise it by just a little bit. Okay, just like that, looks pretty good. So this is the main menu button. And then let's also duplicate this. Let's make this one, rename it. This is the resume button. And inside on the text, let's say resume. Okay, we have our two basic buttons. So let's handle them in the script. So over here, let's add, as usual, a serialized field, private of type button. So that's inside unityengine.ui. So it's for the resume button. And then we're going to have the main menu button. Okay, let's save the script. And back in the editor, let's drag those references. So that's the main menu button and the resume button. Okay. So now for these, let's add the click action. So let's do a private void awake, and on awake, go into the resume button, the on click, and let's add a listener. So this is going to be our listener. And same thing for a main menu button. So main menu. Now for the main menu, this one is super simple. Let's just go into the loader and call the load function. And we're going to load the main menu scene. Okay, that's the main menu, very simple. And for the resume, this one is only going to be clickable when the game is paused. So we can just trigger the same function on the kitchen game manager to toggle the pause. So kitchen game manager, the instance, and toggle the pause game. This one is actually private, so let's go to it. And let's make this public so we can call it from there. Okay, that's it, super simple, let's test. Okay, so here we are, and let's pause the game. And now if I click on resume, yep, there you go, it does work, everything resumes. And now pause again, and now let's go back to the main menu. Loading, and yep, there you go, back in the main menu. All right, awesome. So everything works perfectly. However, there's one sneaky issue here. You can already see the issue by seeing that all of these animations are still, but let's click on play. And nope, look at that issue, everything is still frozen. I cannot move the character, and over there, the shader, that one is completely frozen. So the timescale is still set to 0. Basically, we need to manually reset it. And the simplest way to do this is really just in the main menu. So we can go here on the main menu UI, and we can just use this as our reset function. So let's just go into time.timescale, and let's set this one back into 1F. That's it, that's the only change, let's test. So here we are, let's pause, let's go back into the main menu, and we can see the animations are indeed playing, and if we go back into play, and if there you go, everything works perfectly, we can pause. And yep, here we do see one of the other two sneaky issues left. Basically, it has to do with scene loading and cleanup. So the first one is on input. Over here on the game input class, we are constructing our player input actions, and we are listening to these events. And technically, this object, the one where the game input is attached, this object is going to be destroyed when the scene changes. However, this object that we're creating, this instance of player input actions, this one does not get destroyed automatically. So that is why when I went into the pause menu again for the second time, over here we've got a missing reference exception. Basically, the player input actions of the previous game is trying to show the pause window also of the previous game, which has since been destroyed. So obviously we have a missing reference exception because that object no longer exists. So in this case, we have two options to solve this. One option is we can just unsubscribe to these events. Unity mono behaviors have a really nice callback called onDestroy. So over here, private void onDestroy. So this is the default one. This one is called when the mono behavior is destroyed. So we can go into this one and we can manually unsubscribe. And the way that you unsubscribe is you just do -=. So this would solve that problem because when this object is destroyed, it's going to unsubscribe from those events. So the next time it will no longer trigger. So that would fix it. However, on the game input class, we are still creating a new object of this type. I'm not 100% sure how the input system works in the background, so perhaps this object might stay in memory, which is not good. So another approach we can do, or perhaps in combination with this, is we can unsubscribe and then we can properly dispose of this object. How we do that is very simple. Let's just go into the player input actions and we just call the dispose function. That's it. This should clean up that object and free up any memory. So let's test. So here in the game view, let's pause, let's go back into the main menu. Now let's go back into the main game And now if I hit pause, and if there you go, we no longer have any errors. Okay, so that's good. However, now we still have one more potential issue, and this one has to do with statics. Like I mentioned before, statics belong to the class and not any instance of that class, so that means that static fields will not be destroyed or reset when the scene changes. In the case of our loader here, where we have a private static field, this one, the fact that this one doesn't reset automatically, that was a good thing. That's what allowed us to make the unloading system. But in the case of maybe static events, that might not be as good. It might mean that we might be keeping some state from the previous game, which might cause everything to break. So basically we have a similar problem to what we had in the input, where some logic from the previous game might be affecting the next game. In all the code that we wrote, the main place where we used statics were in the singletons, and these are going to be cleared automatically when the underlying instance object, when that one is destroyed, so these do not cause any problems. However, for example over here on the cutting counter, we've got a static event. When the scene changes, this will not be cleared, so this will still have the same number of listeners. We can actually see how many listeners there are by printing it, so let's go down here before we're invoking the event. Let's do a debug.log, let's go inside the onAnyCut event, and over here we can get the invocation list. This one is the list of all of the functions that are listening to this event, and we can just print out the link to see how many listeners are listening to this event. So let's see what this returns. Okay, so over here, let's pick up some cheese and slice it, and if I look in the log, yep, there you go, 1. There's only 1 listener. Okay, that's correct. However, now if I go back into the main menu, and now I go back and I play again. Okay, so let's play. Let's just wait for the countdown, and once the countdown ends, pick up some cheese, go there, slice it, and there you go, there's the problem. Now we have 2 listeners. In this case, it doesn't really cause an error because the 2 listeners, they're just over here on the sound manager, so we are subscribing to this event and we're doing the cut and playing the cut object. However, if here we do something with this transform, like for example, let's just do a debug.log on this transform.position. If we do this, here let's go ahead on the first one, let's slice, and okay, that works. Let's go back into the main menu, now play again, now wait for the timer, pick up some cheese, go there, slice, and if there you go, there we have our error. That is because we are now accessing the sound manager transform, and that one has since been destroyed. So if you do use static events like this one here, if you do that, always remember you need to manually reset that state. It won't happen automatically on the scene load. And one way that I normally do it is just make a class responsible for doing that. So let's go ahead and let's create a brand new C# class. Let's call this the reset static data manager. And for this one, we want this one to run only on the main menu. That's only where we're going to reset things. So let's go inside the main menu scene. Let's go there. Let's create a brand new empty game object for the reset static data manager. Let's reset transform, just keep things clean. And let's attach that script. Again, it's very important that this object only exists on the main menu. Then over here, we're basically just going to go into any script and reset any data. So for that, on all those scripts, let's make a function. So over here on the cutting counter, let's make a public static function. Let's call this reset static data. And in order to reset any listeners, let's just go into the onAnyCut and set it to null. That will clear all the listeners. So we just do this, and then on this script, let's do a private void awake. And on awake, let's go into the cutting counter under the class, so not any instance. So we're going to access the static, and we're going to reset the static data. That will clear all the listeners on the cutting counter. All we need to do is make sure to do this on every single static event that we have. So on the sound manager, and by the way, here we can get rid of the testing code. Here we can see all of the static events that we're using. So we've got the cutting counter, then we've got the base counter and trash counter. So let's go here on the base counter and paste the exact same thing and reset this event, okay? And now let's go into the trash counter. So here on trash counter, same thing, reset this event, set them all into null. And by the way, here we have a warning. That's because trash counter extends base counter. So basically this is telling us that we are hiding another function with the exact same name. In this case, we do want to hide it. So let's actually make this new to make sure that this one is a different one, just to avoid that warning. And same thing over here on the cutting counter, we also need to make a new. Okay, so that's it. And now we just need to go over here onto the reset static data manager. Let's go into the base counter and reset the static data. Go into the trash counter and reset the static data. Okay, that should do it. Let's see. So here we are in the game, let's pick it up and slice it. And yep, we've got just 1 listener, that's good. Let's go back outside, back into the main menu. Let's play once more. And over here, let's pick it up again, go there, drop it, and there you go, still just one listener, because we are now correctly eliminating all of the previous listeners. So this is the one sneaky issue that you must be careful with when it comes to object lifetime and statics. For static fields, you need to remember that they don't manually get cleaned up. That's up to you. So that's something you have to keep in mind, but you can also see how easy it is to solve. Now that this is solved, let's just go into the cutting counter and just get rid of our tasking log. Alright, so with all of that, all of our scenes are working. So we can start from here from the main menu and go straight into the game. Then here we are in the game playing normally. We can pause the game at any point. From the pause screen, we can either resume or we can go back into the main menu. And from back into the main menu, we can once again play the game from scratch. And if there you go, everything works. Alright, awesome. Now the next thing that every game requires is some options, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to create a simple options menu where we can modify the audio levels. Okay, so here let's make the options menu. So on our game scene, let's go into the canvas and create a new empty game object. Let's make this the options UI. Let's stretch out this one to occupy the entire screen. Then inside, let's make a UI image. Once again, let's stretch out everything. Let's put this one in black in just almost full alpha. Okay. Now let's make some text. So let's create a brand new UI text. Call it the options text. Then for text, let's say just options. Let's put the width and height at 0. Let's disable wrapping, put it center down the middle, and put it quite a lot bigger. Okay, that's the options. Now just move it slightly upwards. All right. Now let's make some simple buttons to handle our audio controls. We're going to make it super simple, literally just a button we can click. So inside the options UI, let's create a brand new button. Call this the sound effects button. Then let's make the button a bit bigger, something like this. Okay. And inside for the text, let's say sound effects, and then we're going to have a number for the sound effects. Let's just quickly change the color. So put the text in white and the button over here, the button image, let's put it in a dark gray. Okay. Let's also make it just a tiny bit thinner, just like that. Okay. So this is the sound effects button. Now let's duplicate this one. This one is going to be the music button. So let's name this the music button. Then inside for the text, music, and then a number. And that's pretty much it. So by clicking on either of these buttons, we're going to increase and then loop the volume. So let's make a simple script to handle our options window. So in our scripts inside the UI, let's create a brand new C# script for the options UI. Let's go ahead and attach a script and open. So here as usual, let's get some fields for our buttons. So a serialized field, private of type button for the sound effects button. And then there's another one for the music button. Okay, both buttons. Now let's add the click events. So on private void awake, let's go into the sound effects button. And on the on click, let's add a listener. And we're going to do the same thing on the music button. Okay, so now when we click, we want to change the volume. So let's go here onto the sound manager and make a function to modify the volume. Let's make a private void change volume. And here we're going to increase the volume by 0.1%, so constantly increase in 10% increments. So that means we need to keep track of the volume. So up here, let's define a simple private float for the volume. Let's default it to 1F, okay. So now down here, we take the volume and we increase it by 0.1F. And now let's loop it back to 0. Now for looping, usually you do it using the modulo operator. So here you could do volume equals volume modulo of 1.1F. That way when it gets to 1.1F, it would reset back to 0. But here, since we're working with floats, which can have a bit of odd precision, with this, let's just do a simple if to make sure that it always works. So if the volume is above 1F, if so, then let's just reset it to 0. Okay. So here we modified volume, and let's just make sure to use it over here when we actually call the audio source.playClip at point. Here we've got a volume, but this is the one that we received as a parameter. So let's actually receive this one, rename this to volume multiplier. And we're going to basically multiply the one that we receive in the parameter by the one that we actually store. So this way on these functions, when we play a certain sound, we can still give an optional volume. if you want to make it louder or quieter than the regular sound effects. Okay, so we have our change volume function. Now we just need to call this from the options UI, so that means this one actually needs to be public, okay? So now here on the options UI, we go into the sound manager, access the instance, and call change volume. Okay, so that is going to change the volume. Then we just need to update the values on the options UI. So let's make a private void, update visual. And this one we need to update the text. So up here, let's add once again some more serialized fields. So text mesh pro UGUI, one for the sound effects text and another one for the music text. Okay, we have both these. Then here the sound effects text.text equals, and we go into the sound manager, the instance. And then we need to get the volume. So over here on the sound manager, let's make a function to get it. So a public float return get volume, and we just return the volume. Okay. So then here let's get volume, except the volume is going to be a normalized value. So rather than showing 0.1, 0.2, 0.3 on the UI, let's just multiply the volume by 10f. That way we show between 1 and 10. Okay, then let's just round out this number and then add the text. So here's sound effects, and then we have the volume. Okay, so that's pretty much it. And up here, when we change the volume, let's just update the visual. And let's also make a private void start. And on start, let's also update the visual. Okay, that's it. Pretty simple. Now let's do the exact same thing on the music. Except on the music manager, we named it music manager, but over here we just have an audio source. There's no actual manager. So let's actually make one. Let's create a new C# script for the music manager. Let's go into the music manager object. Let's attach a script and let's open. So here we really just need pretty much exactly the same thing that we had. So let's just go here into the sound manager and just copy these. So on the music manager, let's paste them. We need a volume, so a private float for the volume, just like this. Okay, so that changes the volume. Except again, the music manager, this one, the music is constantly going to be on looping. So after we modify the volume, we need to update the actual audio source. So let's first begin by grabbing the audio source, and we just do a private void awake. And on awake, let's grab the audio source, get the component of type audio source. Okay, so we have this. And when we change the volume, let's go here and update this volume. Okay, that's it. And let's also default it to something like 0.3f. Okay, good. Then in order to be able to call this from the options UI, we just need to make it a singleton. So as usual, public static music manager for the instance. And we have a public get and a private set. And then an awake, just set instance equals this. Okay. So then here on the options UI, we can go into the music manager, the instance, and change the volume. And afterwards, let's update the visual. And down here on the update visual, let's do pretty much the same thing. So on the music text, modify the text to say music. Then we go into the music manager and get the volume. All right, that's it. All this should be working. Let's just drag our references. So back in the editor, let's drag first the button. So the sound effects button, that's this one. Then the music button, that's this one. Then we have the music text, that's this one. And the sound effects test like that. Okay, let's test. Okay, so here we are, the music is playing, and as I click, the music is currently getting louder and louder. And there you go, music is at max volume, and if I click again, now the music is completely muted. Alright, awesome, and these sound effects also work, so like this, they should be less louder than usual. Okay, great. So everything works perfectly, except obviously we have one big issue. The options window is on top of everything. The goal is for the options window to be kind of a submenu of the pause window. We want to have an options button on the pause window that will bring up the options window. So let's do that. Let's first hide the options window. Let's go into the game pause UI. And over here we have these buttons. Let's just make one more. Let's put it down the middle. This is going to be the options button. And inside, let's modify the text to options. Okay. Now let's edit this script. So we're going to have another button. So this is the options button. And down here, we're going to have another click. So the options button. Okay. And when this happens, we want to just show the options window. So in order to access it, let's make this a singleton. So public static for the options UI, a static instance with a get and a private set. And on awake, as usual, instance equals this. So over here on the game pause UI, we go into the options UI, access the instance, and then call a show function. So we need to make this. So up here on the options UI, let's make those. So a public void show. And this one, as usual, just game object set active into true. And then we have a private void hide, and this set active into false. Okay, we have both these. On the other side, we show it. And over here on start, let's also hide it. Okay. Then let's also hide it manually. So let's add a button to close the options UI. So over here, let's show the options UI and let's make another button. Let's put it on the bottom. This one is the close button. And over here, let's just say close. So then here on the options UI, just make another button, the close button. And down here for the click event, we go into the close button and we just call hide. Okay, so that won't hide the window. However, remember that the pause window can also be closed by just pressing escape. If we resume with a hotkey, it will hide the pause window. So let's also make sure this one hides on the same thing. So we can do pretty much go into the kitchen game manager, the instance, and let's listen when the game is unpaused. So when that happens, let's hide this window. So once again, let's do things nice and clean. Let's rename this. So the kitchen game manager. And when this happens, let's just hide. Okay, this should work. Let's just drag all the references. So first here on the options UI, let's drag the close button. And then on the game pause UI, let's drag the options button. Okay, so let's test. And yep, right away the options window is not showing. That's great. And if I press an escape, there you go, there's the pause window. And if I click on options, yep, there's the options window. Now if I click on close, back here, back into resume, okay, works. Now if I pause, options, and now press on the escape key, and yep, there you go, it closes everything. All right, great. So everything is working fine. However, we have one slight issue. The option does work, so I can modify this to change the sound effects and the music volume. So for example, let's mute the music and put the sound effects on 5. So I put it like this, but now if I stop playing and I hit play again and look in the options, and nope, there's the issue. Basically the data is back to the default. Obviously that is resetting since we didn't actually save anything, so let's save it. Now in Unity, the easiest way to save some data is using player prefs. So let's go over here on the sound manager, and when we modify the volume over here, when we do that, let's access the Unity player prefs, and over here we've got a bunch of set functions. So we can save a float, an int, or a string. This one, as you can see, takes a string and a value. So this is pretty much essentially just a dictionary. Now for the key, as you can see, it's a type string, but again, we should not be using strings directly. So let's go up here in order to make a proper constant. So a private const string, let's call it player prefs sound effects volume. And let's go sound effects volume. Okay, we have our nice certain constant, and down here, when we set the float, let's use this string and save the volume. Okay, so that is going to set the float. And now technically Unity is going to automatically save the player prefs. Basically there are only problems if Unity somehow crashes in between when you call set float and when it actually saves. But if you want to prevent that from happening, you can just go and tell it to save manually, just like that. That will definitely save it. And now we just need to handle loading. So up here on awake, when we have this, let's go into the player prefs and let's use get float. Let's pass in the same key. So this one takes a key and default value, so let's default it to 1f. Basically the default value is used if there's no saved data on this player prefs on this key. So the first time we run, it's actually going to use this default. And this one's going to return the saved value, so let's just set it on the volume. Okay, so that's it. That's all it takes to save some basic data. Now let's do the exact same thing on music. So over here on the music manager, let's first define our private const string for the player prefs music volume. And this is going to be the music volume. Okay, we have our string. And then down here, when you change the volume, player prefs. And let's set the float on this key. And let's pass in the music volume. Okay, and then let's go into player prefs and actually save it. And now up here on awake, let's grab the volume. And it's going to be going to the player prefs in order to get the float on this key. And default value is 0.3f. However, over here on the music, again, we are not spawning the sound afterwards. The sound starts playing right away. So let's make sure to set the audio source volume to the one we grabbed from there. Okay, that's it. So like this, it should be working. So let's test. So here we are, and the music is playing. Let's pause, go into the options. Let's bring the music completely down. So let's mute the music. Okay, the music is gone. And sound effects, let's put it on 5. Now let's stop playing, and now play again. And going to the menu, options, and yep, there you go. The data was indeed saved, and the music is indeed muted. All right, awesome. So here we have some basic data being saved. And also just a quick note related to saving. For this simple game, the sessions are pretty quick, so I didn't include any kind of save system for the actual game data. But if you want to know how to do that, I also have video covering that topic. Okay, so with that, we have our options window working. The volume sliders work perfectly. The next thing we need to add to our options is some key rebinding. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to add key rebinding to our options menu. So here we already have this nice options menu. We can modify the volume of the sound effects or the music. Next, let's handle key rebinding. Okay, so first let's build the elements over here on the UI. So let's create a bunch more buttons. But before that, let's actually make some text on the side and buttons in the middle. So let's create a brand new UI text. Call this move up text. Let's put it on the same size as the other one. So these got a font of 24. So let's put it the same thing, font of 24. Width and height, let's put both of these on 0. And down here, anchor it to the left, okay, down the middle and with no wrapping. Okay, so then over here, this is going to be the move up action. So we have move up, then we have the move down, move left, move right. Then we have the interact alternate, and finally the pause. So these are all of our actions. So let's just make all of these. So rename this. So this one is the move down. Then this one over here is the move left. This one is the move right. This one is the interact text. Then the interact alternate text. And finally the pause text. Now let's just modify the text on these. So that's the pause. That one is the interact alt. Then this one is the interact. Then we've got the move right. Then over here, the move left. And finally, we have the move down. Okay, so those are our labels for our controls. Now let's just make buttons over here on the right side. So let's duplicate one of these buttons. Let's put it over here and put it on something like 50 by 50. So this is going to be the move up button. And inside on the text, this is going to be pretty much just a W, okay? So we have the move up, then we're going to have the move down, move left, move right, the interact alternate, and the pause. So we just need a bit more space, so let's move all of these up by quite a bit. Let's also move the music and the sound effects. So move all of these like that, okay? Let's just name all these buttons. So this one is the second one, so this is the move down. Then over here, the move left, then the move right, then the interact button, the interact alternate button, and finally the pause button. Okay, those are all the buttons. Let's just position all of the labels exactly where they should be. Okay, so here we have all of the options, all of our bindings. Now in code, let's grab references to all the buttons and all the text inside the buttons. So over here inside the options UI, let's add all of those. So first of all, for the text, we're going to have the move up text, then the down, left, right, and so on. So let's just do all of these. So down, then over here the left, then the right, then the interact text, the interact alternate text, and finally we have the pause text. And for the buttons, let's go up here, make all the buttons. So the move up button, then the move down button, then we have the move left button, then the move right button, then we have the interact button, the interact alternate button, and finally the pause button. Okay, so we have all of these references. Over here in the editor, let's just drag them. So let's make sure we drag them all correctly. So let's do it one by one. So the move up, this is the text. And actually it's not that one, so that's already a mistake right there. We want the text from inside the buttons. So let's pick up all of these text objects. So let's go into the options. So text inside the move up, let's grab that one. Then inside the move down, let's grab that one. and the left, and so on. So definitely make sure you grab the right ones. Okay, that's all text. Now for the button, so that's the move up button, then the move down, then the move left, the move right, the interact alternate, and finally the pause button. Okay, great. And just to verify that everything is working, let's give proper names to these objects. So the move up button text. Okay, so I've renamed all the buttons. So now over here, it's much easier to verify that we have the correct references. So the sound, music, and so on. So definitely make sure all of these are correct. Otherwise, you might go crazy when things start to go a bit weird. So make sure these are all correct, all right? Now let's begin by updating the text inside over here. So let's go into our update visual. So we go into this, set the text, and now we need to get the binding text for this binding. So for that, let's make that function on the game input. Over here, let's just comment this out. Then over here on the game input script, let's make a function to get the bindings. So technically we could make something just to grab this player input actions, but again, we don't want the options UI to know what input system we're using. It should work regardless of what input system. So we don't want the game input to return anything of this type. Instead, we want to make a nice layer of abstraction. So for that, let's make an enum to define all of our bindings. So let's make a public, since we're going to access it, enum, call it binding. And over here, let's add all the bindings. So we've got the move up, then we have the move down, the move left, the move right, then we have the interact alternate, and finally the pause. So these are all of the bindings. Now let's make a function to return the binding text. So over here, let's make a public. We're going to return a string. Let's just name it get binding text. And as a parameter, let's receive a binding. Okay, so now here, let's just do a switch on this binding, and basically just match up the enum to whatever action we have. So for example, let's begin with the interact, since these are the simplest ones. So for this one, to get the bindings, we first go inside the player input actions, then let's go inside the player action map, then for the action, so in this case the interact, and then inside we've got the bindings. This is an array of all of the bindings. In our input map, we defined all of the keyboard bindings on index 0. Later on, we're going to add gamepad bindings, but for now, we're going to have the keyboard always on index 0. So over here, going to bindings, access on 0, and let's just do a toString. Okay, so let's just return this, and let's do a default to return always this one, just like this. Okay, so let's do a quick log to see what this returns. So let's do it over here on the game input, just a debug.log, go into there, get the binding text for the interact. Okay, so let's test. And right away, yep, we do see it working. So the interact and the binding is on keyboard/E. But we don't want all of this text, we really just want to see the E. Thankfully, the input system has a really great function for just that. So instead of calling the general toString, let's call toDisplayString. Let's see. And yep, this one does return just the E key. Okay, great. So this is the one that we want. Let's do the same thing for all of the other simple actions. So we've got the interact, then we have the interact alternate, and we have the pause. So these are all the super simple ones. So just going to interact alternate, grab the binding on 0, and for the pause, binding on 0. Okay, so these are all super simple. Now the more complex one is the move. It's more complex because you can see all of the others just have one binding, except for the move over here we have a composite binding. So that's basically a binding which inside has 4 separate bindings. Basically, the way that this works is that when you use a composite binding, all of these are added to the array. So this 2D vector is going to be on binding 0, then the up is going to be on binding 1, 2, 3, 4, and so on. Then the arrow keys, this one is going to be on 5. Then we have 6, 7, 8, 9, and 10. Let's do a log just to verify. So here, if we do one for the move up action, for this one, let's go into the move, and let's print out just the binding 0. Let's do a regular toString. Let's see what this returns. So up here, let's just modify our log to say the move up. Okay, so let's see. And yep, index 0 does have the move to the vector. And now if we print the one on binding of 1, yep, now this one does have the move on the W. So like I said, we can see that all of these composites, these are technically inside that one, but in terms of that array, it's just a flat array. So this one index 0, 1, 2, 3, and 4. So that makes it super simple to add over here. So the move up, down, left, right. And let's just do all these. So we have all the bindings, and over here just 1, 2, 3, and 4. And instead of toString, let's call the display string. Okay, so the binding text, this is all set up. So let's go up here and get rid of our testing code. We can now call this from the options UI. So over here, let's do exactly that. So when we update the visual, let's go into the game input. Let's access the static instance. Let's get the binding text. And this one is going to be the move up. So that's it. This one is going to return a string. Let's write all of them. Okay, here are all of them. So let's see. And yep, there they are, all perfect. WSAD, EF, escape. Okay, great. So the visual is working. Now let's handle the rebinding. So let's add a click event. Let's go into the move up button. Let's go into the on click. Let's add a listener. And for the listener, over here, let's make a function on the game input to rebind this binding. So over here on the game input, let's do a public void rebind binding, and we receive a binding. Now for rebinding, I covered this in detail in the dedicated input system video. First, basically, we need to disable the action map. So let's go into the player input actions. Let's access the player and disable it. So we need to do this first. Then we're going to need to find the action. So player input actions. And for now, let's go into the player and let's just modify the move up action. So we're going to call the function perform interactive rebinding. This one, as you can see, takes a binding index. And if you remember up here, we saw that in order to modify the move up, it's on bindings index 1. So let's modify the one on index 1. Okay, so this is the function. This returns an object of this type, a rebinding operation. This is a pretty complex object where you can modify all kinds of things, add a bunch of limitations and so on. Like for example, make a key not be able to be bound to the mouse or something. So there's tons and tons of options you can play with. Over here for the simple thing, let's just add an onComplete listener. So this one takes in a callback, and this will be called whenever the interactive rebinding completes. So over here, let's define a lambda, so a callback, and inside we have this. By the way, over here, this is the same lambda expression that we saw previously. So exactly the same thing as this, except when we have just one parentheses, we don't need to add them. Okay, so like this. So then on this callback, we can see all kinds of things. Like for example, we can see the action that we just rebound. This is going to contain all the data on the rebind operation. So for example, let's print out the path. So let's go into the action. Let's go into the bindings on index 1, and let's print out the path. So let's do a debug.log. And there's actually another one. So let's log the path and also the override path. These are two different things. Let's see why in a bit. We do this, and after we log, we also need to re-enable the player action map. So let's go into the player input actions, the player, and back enable this. Okay, so we're only going to need these settings on the rebind action. Then we can just call start in order to start the rebinding process. Okay, so this should work. Let's just call this from the options UI. So over here we have the click. Let's go into game input, instance, and let's rebind the binding. And for this one is the move up. Okay, with this, let's test. Okay, so here if I click on the button and now I click on the T key, and if there you go, it did work. So you can see that it print out the regular path, that is W, and the override path, which is T. So now if I exit out of the options, go back into the game, if I press W, nope, it does not move, but if I press T, yep, it does move upwards. Okay, great. So we have successfully rebound this one key. Now here, just one thing. In previous versions of the input system, when doing a rebind operation, you needed to manually dispose of this callback, otherwise it would throw a memory error. In the recent version that I'm using here, there's no error, so it seems perhaps it's no longer needed to dispose of the callback manually, but still there's no harm doing it just in case. Over here, callback.dispose. Okay, so with that, the key rebinding is working, except we have two issues. The first one is that it's not very clear that it's listening for an input, and the second one is that the text options also does not update. So let's solve both those. First, let's add a visual when waiting for a key press. So inside the game options UI, let's create an empty game object. Call this the press to rebind key. Let's stretch it out, so put it on 0 on everything. Okay. Then inside, let's add a UI image. Let's put it in black, and once again, let's stretch it out. Okay, now let's also add a simple text. And for text, let's say press a key to rebind. As usual, let's put the width and height on 0, put it in bold, center down the middle with no wrapping, and increase the size by quite a bit. Okay, so that's our super basic window. Now in the code, we just want to show and hide this, so let's do that. And let's actually begin with this hidden by default, so let's disable this object. So here on the options UI, let's add another serialized field. It's going to be a transform for the press to rebind key transform. So you have this, let's make two show and hide functions. So we show press to rebind key. We just go into that one, game object set active, this one into true, and another one where we set it to false. So just hide and set it to false. Okay, pretty simple. Let's make sure to hide this over here on our start. Okay, just like that. And for showing, let's show it when we actually rebind an action, so right in here. But since we're going to have tons of listeners to these events, let's actually make a nice separate function to handle all of the rebinding logic. So down here, let's make a function, rebind binding. We receive a game input.binding. And then first we show the press to rebind key. And then let's go into game input, access the instance, and tell it to rebind the binding and pass in the same binding. Okay, so we have this, and now up here on the button event, let's just call in this function. Okay, very simple. So this will work for actually showing the window, but now we need to know when to hide it. And for that, let's use something that we've used a few times in this course, but never directly. Let's use a C# delegate. As usual, I have a dedicated video on them. This is basically how you can define a field or a parameter of a type which can hold a function. It's another super useful C# feature. Definitely watch that video to learn all about it. Let's go here on the game input, and down here when we have our rebind binding, over here let's receive a second parameter. This one is going to be of type action. This is one of the built-in delegates. It takes no parameters and returns void. So this one is perfect for a simple callback just like this one. Let's call it on action rebound. And we're going to trigger this right here after we achieve the callback. So we get the callback, let's trigger this just like that. And let's also get rid of these testing logs, we no longer need them, so just like this. Now back here on the options UI, so we've got that, and for the second parameter, let's just pass in the function to hide that window. So hide the press to rebind key. That's it. Again, remember, we're passing in the function itself, we're not calling it, so there's no parentheses. We're just passing in the function itself. Okay, so with this, let's test. So here on the options, let's rebind the move W, and there you go, it does show up the window, and now if I press a key, yep, there you go, that one hides. Okay, great. So this is working, but over here the text is still not updating. So over here on the second callback, instead of just calling this function, we need to call this and then also call the update visual function. So as usual, let's use a simple lambda expression to do exactly both. So let's open and close the parentheses, and we do exactly this. So we hide the press to rebind, and then we update the visual. Okay, that's it, let's test. So here we are, let's rebind the move W, press on the T key, and there you go, it did rebind and it did update. All right, great. Now let's just apply this to all of the other bindings. So first up here on the buttons, let's set listeners to all the buttons. So that's the move left, actually the move down, then the move left, move right, the interact button, the interact alternate button, and finally the pause button. And for the bindings, this one is the pause binding, the interact alternate, then the interact, then the move, this one is the right. Again, make sure you don't make mistakes here, you call them the exact same one. So the move down, okay, so all of it is correct here. And over here on the player input, let's do a switch on our binding. So K's move up, we do something. And now we could write this code directly up here and then make a move down and write a bunch more code. That would work, but that would be way too wordy. So let's write our code in a nice clean way. Basically, the only thing we need down here is we need to know the actual action we're going to rebind, and we need to know the action index. So let's just find up here exactly that. So an input action for the input action, and then an int for the binding index. Okay, and then over here, when we have the switch for all of our bindings, we just set those. So the input action, in this case, it's going to be the player input actions, player, and it's the move action. And for the binding index, this one is on index 1. Then we're going to have the other moves. So the move down is going to be on index 2. Then left and right. These are on index 3 and 4. Okay, so we have all these, and now for the other ones. So for the interact, this is the interact action on binding 0. Then we've got the interact alternate and the pause. So interact alternate and the pause. And this one is the pause action and the interact alternate action, and all of them are on binding index of 0. Okay, so that's good. So over here we are assigning the input action and the binding index. And also one thing, we need to make sure to always assign these values. So let's make sure to add a default here, just make sure it always works. Okay, great. So now down here, instead of always accessing the move, let's access whatever is stored in the input action. And for the binding, whatever it is on the binding index. Okay, so now this will work with all of our bindings. So here we are, and let's try rebinding all of them. So let's put them over here on the side. So for the move up, let's put it on T, down on G, A on F, then D on H. For the interact on Y, interact out on J, and for the escape, let's put it on E. Okay, so all these keys have been rebound. Let's just make sure they work. So here I am moving with these keys, and yep, it does work. Go up here to interact, and do the alt interact, and now the pause, and yep, there you go, everything works perfectly. All right, awesome. So everything worked perfectly, although again, we have the same issue as previously. So all the keys have been rebound, so it's all correct, right? However, now if I stop playing, and now if I play again, and nope, there's the issue, the rebinding was lost. So just like with the sound, we also need to save the new state. Now, thankfully, the new input system has a function that makes that super easy. Let's go down to where we are rebinding things. And when we finish rebinding, let's just go into the player input actions. And let's call this function the save bindings overrides as JSON. This one is going to return a JSON string. Now, if you don't know what is JSON, go watch my quick video on it. Basically, it's a super easy to understand and widely used file format. It's very easy to read and modify. It's a format where it's stored as just text. So let's look at what this says. Let's do a debug.log over here after rebinding something. Let's see. So here, if I rebind one of these, and if there you go, there we have our JSON. So the override bindings, it overrode the move on this ID on this new path. So basically, we just need to store this string somewhere. And just like we did with the sound, let's just store it in the player prefs. So first, let's define our constant. So private const string for the player prefs bindings. And let's call this the input bindings. Okay, just like this. So then down here, after we rebind the key, let's go into player prefs and let's set a string on the player prefs bindings. And we're going to save the overrides as JSON. And after we do, let's just make sure the player prefs is correctly saved. Okay, so that saves it. Then let's go on awake to load it. So over here on awake, let's load that. Let's first do a quick test to see if there's a save. So if the player prefs, if it has a key, and if it has this key. If so, then let's get it. So the player prefs, let's get the string on this key. That returns the string, and we're going to use the string. Let's just go into the player input actions. And let's call the function load binding overrides from JSON just like this. And also let's make sure we do this right after we construct the object and before we enable the action map. Okay, so that's really it. Let's test. So here we are. Let's rebind the move up to T. Okay, it rebound. Now stop playing. Now play again. And yep, here it is, still rebound to T. All right, awesome. Okay, so here we created a really nice options menu where we can modify the volume and rebind keys. The only issue that we still have is that we can only navigate the menus with the mouse. So let's add support for menu navigation with a controller in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to set up full controller support for our game, including regular actions and menu navigation. Okay, so first let's just set up the controller inputs. I have an Xbox gamepad controller connected. So let's open up our player input actions. And over here we have all of our actions, and we already made the move one a long time ago. So let's just add the bindings for the other ones. For example, over here on the interact, let's add a brand new binding. Let's go into the path and listen. And for interact, I'm going to press the A button. And again, here you can specify just the A button on an Xbox controller, or you can use the generic South button, which will mean A on an Xbox, or cross on a PlayStation, or B on a Switch, or anything else. So let's go with the generic one. For the internet alternate, let's add a binding, and for this one I'm going to put it on the X on the Xbox, so the button west. And for the pause, let's listen, and I'm going to press the menu, which is the start button. Okay, so these are the basic inputs. Let's make sure they work, and thanks to this new input system, we really don't need to modify any code. Let's just save this asset. Let's wait for the compilation, and then we can do a test. So here we are, and yep, I'm using my controller to move. Now let's just wait for the countdown. And go up there and pick up a cheese, put it, and slice some cheese. Yep, I can do that, pick up a plate, and so on. Alright, so everything works. Let's also pause, and yep, that also works. Okay, great. So everything works, except there are two issues with the gamepad, especially one with the movement that I only noticed just now. The first issue that we have is the dead zone. Right now we don't have one, so if I just lightly touch my gamepad joystick, there you go, it starts moving automatically. In gamepad games, you should always have some kind of dead zone to prevent any kind of Joy-Con drift. Thankfully, that is super easy to solve. Let's just go into the player input actions, let's go into the move, find the left stick binding, and over here for the processors, let's add one, and let's add a stick dead zone. So that's it, pretty simple. This basically considers that inputs under this minimum to be 0, and above this maximum to be 1. So if you have joystick drift, where when the joystick is idle, it's always moving by, say, 0.1 in any direction, this helps solve that problem. Except in our case for our game, we're only using normalized inputs. So actually, for our use case, let's increase the minimum by quite a bit. I did some testing and 0.5 works quite great, and the max at default, that is just fine. Okay, so that's it, one problem solved. Let's just go ahead, save this asset. Now the other bigger issue that we have is if I approach a counter and I try to look at it, it's really difficult. It tries moving left and right instead of actually facing the counter. That's because of the logic that we added a long time ago, that logic to help the character controller feel better when moving on diagonals against a counter. That works great for keyboard because it's digital, so it's either moving fully left, fully right, or on the diagonals. But it messes up the controller, which is analog. On the player movement, if we are not moving perfectly up or perfectly down, then it's considered a diagonal. And on the gamepad, it's really difficult to get a perfect just up or just down input. We're always going to have a tiny bit of either left or right. So that's the issue that we have here, and thankfully the solution is actually pretty simple. Let's go over here onto our player script, and let's scroll down into the handle movement function, okay? So we're doing a can move using the regular move direction, and if it doesn't work, then it's over here that we are attempting only the X movement or only the Z movement. And for doing that, we made it so we can move if there's nothing only on the X, and if we have any movement at all on the X. So if it is different from 0. Basically, the issue here is if the moveDeer.x is, let's say, 0.001, that is still different from 0, so it is still going to trigger this logic. So basically, let's just widen this gap. Instead of testing literally just different from 0, let's test if the moveDeer.x, if it is under, say, minus 0.5f, or if moveDeer.x, if it is bigger than plus 0.5f. So instead of being exactly just on 0, we're only going to consider diagonals if we are at least moving 0.5 either left or right. So we just do this, and same thing over here, except we just test for the Z. So the moveDeer.z and the moveDeer.z. Okay, so like this, it should feel much better on the gamepad and still work exactly the same on the keyboard. So let's test. So here I am moving around, and yep, now it is much easier to just stay around and look straight at a counter. Okay, so that's great. So I can pick up, and this is all much easier, and the character is no longer just sliding left and right nonstop. Okay, that's great. So now that this is working, let's add support for rebinding our controller bindings. So over here on the game input, let's do it just like we did for the keyboard. So let's add a bunch more bindings over here on the enum. Let's add the gamepad interact, then the gamepad interact alternate, and then the gamepad pause. Okay, so we have our bindings. Then let's go down and add them to both our functions. So first the text and then the bindings. So over here on the text, let's copy pretty much this. We're going to have the gamepad interact, then we're going to have the other two, so the gamepad interact alternate and the gamepad pause. Okay, now for